Okay, we're going to go ahead and take a look at section 3 here. We're going to be dealing with some properties of logarithms to help us solve equations. Now, when we're looking at the following here, we have three statements that are true when you're dealing with logs. See if you can go ahead and see the pattern of what you're doing on the left to get to what you're going on the right. Now, as we look here, maybe with some color coding, it will help you. Also, make notice that we have multiplication here, addition here. We have division here. We have subtraction here. We have an exponent here that really gets put down in front. So these are the properties of logarithms. When you have two things multiplied after a log, you can break it apart and go log of the first one plus log of the second. When you have two things divided after one log, you can go log of the first one minus log of the bottom. And then when you have an exponent after a log, you can put it down in front. And that's our properties of logarithms. So you want to make sure you have these properties on your reference sheet, and or if they're already on your reference sheet, make sure you are knowing where they're at. So now we're going to look at some problems where we're applying these properties. So here we have an exponent after a log. You're going to just go ahead and put that exponent down in front, and it becomes just a nice normal number in front. Here we have multiplication after a log, so you can go log of the first one plus log of the second one. And that's referring to this one here. Now just be aware that these are equal signs. So sometimes you'll be on this side here and you'll go back to this. Other times you'll be on this side over here and you'll go back to this one over here. An equal sign goes both ways. So that's the way it is with all of these. So just be aware of that. Now when we're looking at this one here, we have one log and we're dividing afterwards. So that would be this one here. We have one log dividing what's afterwards. It says we got to go to the log at the top minus the log of the bottom. So let's see if we can use properties of logarithms to help us out here. Once again, we have multiplication. So here we have multiplication on this one here. It says we can break it apart. Now here we have a base of 9, so you're going to go log base 9 of the first number plus log base 9 of the second number, which is our 5, plus log base 9 of our last number, which is that 7 squared. So now I'm going to just bring down that log base 9 of 6 plus log base 9 of 5 plus, but you notice here we have an exponent after log. Our properties of logarithm says we can put it down in front. So I'm going to put that 2 in front, and then it'd still have my log base 9 of 7. So that's what it's like to take one logarithm and expand it, and that's what our directions are saying to do, is to expand our logarithms. Now, when we look at our problem here on the right, we have division, so that's referring to this one here. So I can go log base 2 of that top number minus log base 2 of that bottom number. But then, once again, we have an exponent after our logs, so we can use that bottom one. We can take our exponent, put it down in front, our exponent, put it down in front. So I'm going to go log base 2 of 6 minus log base 2 of 5, and put our exponent of 2 in front of the first log, put our exponent of 3 in front of that second log, and there we would have our expanded form. Now, as I mentioned before, these equal signs means you can go from one side to the other side or vice versa. And so that's what we need to do here. We have these expanded logs. We need to put them back together. And you notice on our last problems, the last thing that we did was deal with the number front, which came from your exponent. So when we're working backwards, we're going to have to take each one of these up as your exponent. So then we would have log base 3 of an x raised to the 5th minus log base 3 of our y raised to the 6th. You now have a log minus a log, which is this, so we could put it together as 1 log base 3, and then you divide what's afterwards. You're going to take the first one here, and that goes on top, divided by the second one. And then we'll do the same type of thing on our next problem. Once again, you have to deal with those numbers in front first, putting them up as exponents. So that 10 goes up as an exponent on your x, that 2 goes up as an exponent on your y. We now have a plus sign, and that's this one right here. So we can write it as 1 log and multiply what was after our 2 logs. So we're going to take this, put it first, followed by this one, and we'll put it second after our multiplication. And so that's going ahead and using our properties of logarithms to expand and condense our logs. So using our properties of logarithms both ways. So now we're going to use our properties of logarithms to help us go ahead and solve these problems. You'll notice here on the left we have a log minus a log. So that means we're going to use this one here. And so I'm going to write it as 1 log, and then I have to go ahead and divide what's afterwards. Now, we dealt with problems like this in the prior section. We have 1 log on one side, so this is in the log form. So I'm going to take my base, swing it over, and it hits up that 2 as the exponent, and this will be equal to that. So in other words, it's using my definition of a logarithm from section 2. So now what we have is really a fraction equaling a fraction. 9 squared is really 81 over 1. So then we can multiply both sides by our LCD. And on the left, that one drops out, that one there. We're left with an x on the left. Distribute through my 81. And then just solve it like normal. I'm going to add an 81 to both sides, subtract an x from both sides. And then we divide by the 80. And my computer undid too much, so I had to rewrite. And so we would get this. Now, the one thing you need to remember from what we were talking about before is whatever's after your log always has to be positive. And we started out with variables after a log, so we have to check our answers. Now, if you did do the approximation of this, it would be about 1.0125. If we would take that and put it here, that ends up being positive. Also, if we take that number and check it here, 1.0125 minus 1 would be a small but still positive number. So yes, both of these answers will work. Now, in this case, if you wanted to do the approximation, you can. It did just said to solve. You wouldn't necessarily have to. So in our problem here on the right, we do have logs being added, so that would be this top formula right here. So then we're going to go ahead and write it as 1 log and multiply what's afterwards. And if we multiply what's afterwards, multiply this through, basically I can distribute through that x into my x plus 13, and I get a 13x here after my x squared. So now we have 1 log on the left and we have 1 log on the right. When you have 1 log on each side like this with the same base, then what's afterwards also has to be equal. And so then when we set what's after our logs equal, and you can do that when it's 1 log equaling 1 log, it ends up being a quadratic. And you know, to solve a quadratic, all you have to do is to go ahead and set it equal to 0 to solve it. And then you could try to either do your AC factoring or the quadratic formula. In this case, it does factor quite nicely. But if you wanted to do the quadratic formula, it would not make a difference. And then if you're doing the factoring, you'd have to go ahead and set the first one equal to 0, and you would get x to be equal to negative 17. Set the second one equal to 0, and you would get x to be equal to positive 4. Now, remember, whatever's after your log has to be positive. If I go ahead and try taking my negative 17 and plugging it in here, that would be a negative 17 after a log, and you cannot have a negative after a log. So in this case, the negative 17 does not work. And so yes, we got that from solving it, but it doesn't work. So we did not make a mistake in solving it, but it just doesn't work in the original problem. If we try this one right here, plug a 4 here, well, that would be positive after a log. If you plug a 4 here, 4 plus 13 would be positive after a log. So that causes us to have a positive after a log, so the only answer that works is just 4. One last problem here. We have a log minus a log, so we're going to use our properties of logarithms, which is this one here, and we can write it as 1 log, and then you have to divide what's afterwards. Now, in this case, you only have one log on each side. They're both the same, so therefore what's afterwards has to be equal. And so then you can set that equal to each other, which is really ending up being a fraction over, or equal a fraction. Multiply both sides by your LCD. And here on the left, that x drops out that x, so you're left with just an x plus 6 is equal to 55x. Subtract an x on both sides. And then we can divide by 54, and that simplifies to a 1 over 9 is equal to x. So then you have to verify that it actually does work. If you plug 1 over 9 in right here, that would be positive, so that's fine. If you plug in 1 over 9 and add 6, that would be positive, so that's fine. So this is your answer. So to summarize in solving equations, if not all the terms have logs, reduce it down to a single logarithm. Then you want to go ahead and put it into the exponential form to finish solving it. If everything has logs, reduce each side to a single logarithm and then drop the logs, but just don't drop the logs on your foot. So just be aware of that. And then there's a couple of properties there at the bottom that you might want to be aware of. Might come into play once in a while.